I'm really excited. Our last sort of rocket scientist talk for the day will be Sarah Baldwin from the Aerojet Rocketdyne company. I'm very excited about this because Aerojet Rocketdyne is actually a legacy aerospace company that started right here where the Space Center is. They started as a division of North American Aviation back in 1950 and were part of that group here on site for many, many years. Rocketdyne actually has built, up until the SpaceX launch not too long ago, they built every single rocket engine that took an American into space. That's pretty amazing. We're excited to talk to them. I'd like to welcome our special guest from Aerojet, Sarah Baldwin, who is a rocket scientist and is going to tell us more about it. Sarah, how are you?
I'm great. How are you doing?
Good, good. Thanks for being here. I know you're based in Southern California, so it's a hot day today, but thank you for joining us virtually. I'm really excited to hear what you have to say because, again, this Aerojet Rocketdyne has a very special place in our heart here at the Space Center because we are on the land that you used to be on. And how long have you been with the company?
So I've been with the company 10 years, and then I interned actually before that. So
Oh,
yeah,
cool.
it's been a great year.
Cool. Well, I'm excited to hear more and probably ask you some more questions after this, but I know you have a presentation, so
Yeah.
take it away, Sarah. Thank you.
All right, thanks. So as you said, my name's Sarah. I'm an aerospace engineer at Aerojet Rocketdyne, and I work on the RS-68A engine, which is the world's most powerful liquid hydrogen, liquid oxygen engine, and it actually powers the Delta IV rocket. So my job involves traveling to the launch site and working launch countdowns to make sure that every payload safely reaches orbit. And right now, we're actually working towards a launch in about 2 weeks. Next slide. All right, thank you. So one of my favorite things about working in the space industry, and specifically at Aerojet Rocketdyne, is being able to be a part of space exploration. Our propulsion systems have visited every planet in the solar system and even some asteroids as well. Now, my personal favorite is the Parker Solar Probe, which I might be a little biased about because I helped launch that a couple of years ago. And it's been just so much fun watching it closer and closer to the sun. And eventually it's going to pass within the corona of the sun. And our propulsion systems have actually visited Mars 9 times. And after Perseverance lands, that will be our 10th time onto the red planet. Next slide. Thank you. So there's a lot of really exciting things that are happening in space exploration right now. So I wanted to talk about a couple of them. Starting with the Mars 2020 launch, that's bringing the newest rover Perseverance to Mars. So the rover launched just a few weeks ago from Cape Canaveral aboard a ULA Atlas V rocket. Now, 4 of our AJ-60 solid rocket propellants helped lift the booster up off of the pad. And it may be hard to tell from that photo there, but each of those solid rockets are 55 feet tall. And together, they provided over 1.4 million pounds of thrust. And then after that first stage separated out, our RL-10C liquid hydrogen, liquid oxygen engine, upper stage engine propelled Perseverance on its trajectory to Mars. Next slide. Thanks. So let's talk a little bit about getting to Mars. So launching a spacecraft on an interplanetary mission requires really precise timing. Earth and Mars orbit the sun at really different speeds and different distances. So in order to be as efficient as possible and minimize the amount of propellant that we have to take with us, we need to make sure that we launch at a time when the planets are at a good position relative to each other. And this optimal alignment only occurs once every 26 months. So we need to make sure we launch on time. So right now, Perseverance is in its cruise phase. And just yesterday, it performed the first trajectory correction maneuver, or TCM as we call it, to put it on a pathway to intercept Mars. So the next TCM is going to occur in September, followed by 4 others prior to landing in February of next year. Okay, next slide. Thanks. So now let's talk about getting onto the surface of Mars itself, which is a really cool and complicated process. So during entry to Mars, Perseverance will first eject the cruise stage that used to get to the planet, and then that cruise stage will burn up in that thin Martian atmosphere. And it has a heat shield that will then protect it from the heat of the atmosphere entry, which can get as hot as 3,800 degrees Fahrenheit. Then during that time, 8 of our thrusters will be firing to help stabilize that spacecraft as it starts to slow down. And there's 2 things that slow it down. The first is that the atmosphere itself will cause some friction. And the second is that curved underside of the heat shield will actually cause some lift, slowing it down. And those 2 things combined will slow it down from 13,000 miles per hour down to just 1,000 miles per hour. But that's still too fast to land on the planet. So then it will deploy parachutes that will help slow it down once it's about 7 miles above the surface. And then at that point, it will eject the heat shield. Then when about 80 seconds later, it'll eject the parachutes and the back shell as well. And then at that time, 8 of our thrusters will then fire to help push the rover away from all that hardware so they don't crash together. And then finally, my favorite part, which I think is just so cool, is the sky crane. And so the sky crane is also powered by our thrusters, and it will then gently lower the rover down to the surface for a nice gentle landing at less than 2 miles per hour. Now, the sky crane was first used back on the Curiosity mission, and it was a really innovative new landing method. Previous missions had used parachutes, they've also used descent engines, and even these inflatable airbags for a bouncier landing. Next slide. Thanks. Okay, so then let's talk about the mission itself. So once the Perseverance rover is safely on the surface of Mars, it can then begin its roughly 2-year journey to collect samples from the surface. And it's searching for signs of ancient microbial life. And that will help not only explore the past habitability of Mars, but it'll also help prepare for future human expeditions to the planet. So Aerojet Rocketdyne provides the multi-mission radioisotope thermoelectric generator, which we call MMRTG for much shorter, and that will provide power to the rover. And that MMRTG is a nuclear power system, so it converts heat from the natural decay of radioisotope material into electricity. And the first mission to use one of our MMRTGs was the Curiosity rover that landed back in Mars on 2012, and almost 8 years later, it's still going to this day. Next slide. Okay, so now that we've talked a little bit about getting to Mars, let's talk a little bit about our path about getting humans to Mars. So the first step to getting humans to Mars is actually to return to the moon. And NASA's Space Launch System aims to get us there by 2024. So the 3-day journey from Earth to the moon allows us to practice living and working long-term on another astronomical body before we actually have to commit humans to that really long journey to Mars. And our AR engines, as you mentioned, propelled astronauts to the moon back in Apollo, and we're really excited to be a part of that going forward with these Artemis missions. Next slide. Okay, so Space Launch System, or SLS, will return people to the moon and eventually launch them to Mars. Now, the first stage of SLS will use 4 Aerojet Rocketdyne RS-25 engines, which are actually derived from the engines that were used on the space shuttle. In just 4 seconds, these engines will reach over 2 million pounds of thrust, and they'll run for 8.5 minutes. Now, these engines, they operate in really extreme temperatures, with the liquid hydrogen cools the hardware down to temperatures of minus 423 degrees Fahrenheit, which is cold enough to liquefy the air around the engine. But then once it combusts, it actually runs up to temperatures of 6,000 degrees Fahrenheit, which is hot enough to melt steel. And then the AR-RL-10 engine will provide the main propulsion once that rocket is in outer space. On its inaugural flight, Artemis 1, it'll have 1 RL-10 engine, which will take an uncrewed mission on a demonstration lunar orbit. And then the second flight, Artemis 2, will carry astronauts on that lunar orbit. SLS will be able to initially carry 60,000 pounds of payload to the moon. And then later versions will be able to carry over 100,000 pounds of cargo and crew to the moon. Next slide. Thanks. So right now, we're in the process of preparing to do a full system checkout of the SLS First Stage at Stennis Space Center, which is located about 1 hour outside New Orleans. So on October 9th, we're going to do what we call a wet dress rehearsal, where we load all those cold cryogenic propellants into the tanks, and then we perform various test sequences without actually lighting the engines. On October 20th, we'll do a full static fire test, where we actually do run all 4 engines together for 8 minutes to simulate the duration of that launch. And it's really exciting because when we perform just one single engine testing, you have the hydrogen and oxygen combining together, and it makes this really massive steam cloud that's so big it'll rain down on you. But it's going to be incredible seeing all 4 of these engines running together full duration. And I hope all of you can watch the videos of that. Tests like these for me are actually more fun to watch than an actual launch, because you get to see and hear the rocket for much longer than you would during a launch. Next slide. Thanks. So the Orion spacecraft will be capable of taking crews to deep space destinations and returning them to Earth safely. Now, one of the challenges with bringing humans into deep space is the potential exposure to radiation. But Orion is designed to provide up to 1,000 mission-capable days to protect the crew from that radiation. And the Orion spacecraft actually had a demonstration test flight that was nearly flawless back in 2014. And I was actually part of the launch crew that helped launch that on the Delta IV rocket. And we launched it to a peak altitude of 3,600 miles above the surface of the Earth before it came back with re-entry speeds of 20,000 miles per hour before it splashed down in the ocean. So one of the benefits of going back to the capsule design is that it's much easier to separate the capsule from the launch vehicle if there's any emergency that were to occur. So our Aerojet Rocketdyne launch abort jettison motors can quickly pull that capsule away from the hazardous situation, keeping the astronauts safe. And then once in space, our propulsion systems provide the Orion capsule with the primary propulsion power, the steering capability to make sure it's in the right trajectory, and also control to help as it re-enters the atmosphere to make sure that you come in with the right orientation with the heat shield down. Next slide. So NASA's Gateway is another important piece of our return to the moon and to future space exploration. Gateway will essentially be a human space station that orbits the moon and allows astronauts to have a habitable place to stay once they get there. And then having an orbiting lunar station allows for multiple trips down to the Earth's surface and actually going to different locations throughout the surface. And in the future, the Gateway could be a stopping point as you go on missions to Mars or further deep space exploration. Next slide. Okay, so NASA's Cirrus Rex is another exciting mission that's taking place right now. It was launched back in 2016. It's currently orbiting the asteroid Bennu, and it's going to land on the surface on October 20th to collect samples. Those samples will be returned to Earth for scientific study in about 2023, and it'll help us better understand how planets are formed. Now, just this past Monday, the spacecraft performed a rehearsal of its landing on the asteroid, approaching about 130 feet above the surface. And Aerojet Rocketdyne provides 28 of the rocket engines on the spacecraft, which first slowed it down over 1,000 miles per hour to match the orbit of the asteroid, and then it will maneuver it on and off the surface of Bennu. Okay, next slide. And then as we look forward to deep space further deep space missions, we also need to consider systems that don't rely on traditional liquid or solid chemical propellants, which you have to bring those propellants with you, which adds mass to your launch system. Relying on alternative methods could enable longer duration missions as well. So solar electric propulsion uses solar panels to collect energy from the sun, then it converts that energy into propulsion, essentially converting photons into ions. And that solar electric propulsion is a really efficient way to move through space, but it does have a lower thrust than you would have with traditional propellants, so you travel at a slower speed. So because of that, this type of propulsion would be ideal for transporting cargo or non-crewed missions throughout the solar system. And Aerojet Rocketdyne is currently working on a range of different products that use solar electric propulsion to support our future missions. Next slide. Okay, so another option is that we're working on at Aerojet Rocketdyne is developing nuclear thermal propulsion, which is twice as efficient as traditional rocket engines. Now, nuclear propulsion works by using nuclear energy, which heats that liquid hydrogen, which can then be accelerated to produce these high levels of thrust. Now, the thrust from nuclear propulsion is much higher than chemical propulsion, which makes it an ideal propulsion system for crewed space missions for deep space exploration, because you're traveling at such a high rate of speed. And with your faster journey, you could reduce travel time and also reduce the crew's exposure to that radiation we talked about. Okay, next slide. And then additive manufacturing, which you heard Relativity talk a little about, we also call it 3D printing, is quickly growing in the space industry. Being able to 3D print your parts for rocket engines not only saves you time, but money, and it also allows you to create parts that are engineering designs that are so complex that previously you were limited by the capability of prior traditional manufacturing methods. So currently we're working on additive manufacturing on multiple products throughout our company, and I'm really excited to see where this technology goes in the future.
All right. Thank you very much, Sarah. Thanks for giving us not just sort of a little bit of a history lesson, but also a peek into the future of where you guys are going. It's fantastic. You know, we got some questions from out there in YouTube land, and I did want to ask. Caroline F asked, "Do you get your rocket engines back?"
No, we don't actually. So especially the ones that I work on, the primary focus was to make a very cheap engine. So it's made to be used one time. And so the engine I work on is not, but the space shuttle main engines, a lot of those have seen many, many flights, including a lot of the ones that we've been working on that are going on to the Artemis missions were actually initially shuttle engines that we pulled off the orbiters before they went to the science centers. So
right.
what you see Endeavour, that's actually a nozzle on a stick that we put in so that we could keep those engines. And we've been able to introduce those improvements we've been making to the designs. And so those will launch on Artemis and have seen many private flights as well.
Oh, that's awesome. That's awesome. You know, I get two more questions, actually. There was one from Astra Athens, and how much shorter will a trip to Mars be using nuclear fuel? You had talked about the nuclear propulsion system.
Yeah, you know, I would say with that, you know, if you're going to use a traditional cryogenic propellant like you know, the LOX fuel LOX hydrogen, sorry,
Yep.
it's twice as efficient. So I would expect it to be about twice as fast.
Oh, right. So what, it's a 9-month trip down to 4.5, maybe? Sounds good.
Yeah, yeah, it would be a big improvement for the crew. I'm
Yeah.
sure they would appreciate it.
Absolutely. So the other question I have is, Sarah, how did you get into this? You've been working at Aerojet Rocketdyne for 10 years. What inspired you to become a rocket scientist?
You know, I grew up in a really small town in Indiana, and I right near Purdue University, about 2 hours away. And I decided to go to Purdue University, but it just seemed like it was so far away to be a part of the space industry. That's something other people did. I didn't even know how you would get into that. So I decided on engineering and went to Purdue. And once I got there, I found out they had more alumni astronauts than any other school. So we'd be going to class, and Jim Lovell came and talked to us. Neil Armstrong, I saw him on campus my sophomore year. It was really exciting. So once I got there and I met other students, I actually switched into aerospace engineering because I realized it's really not outside the reach for anyone to get into. Mm-hmm. It's just, you need to know that you can do it. And so yeah, it was just kind of knowing that the opportunities are out there. And I think Purdue really helped me do that.
So when you say that you had to know that you could do it, was that more of awareness that this was something that you could do, or was it something that you felt like you needed to, I don't know, like somebody had to tell you, like, no, Sarah, you can do it, or how did that work? And what would you say to encourage other young people out there who are watching this?
I would say, you know, just an engineering degree is a great way to start with it. There's a lot of other science degrees, But I would say, yeah, I mean, there's so many companies out here now that there are just a ton of opportunities. So, if you think you are wanting space, wanting to work in the space industry, try some clubs, try, first robotics, try, when you get to college, try a design build test. But really, like, there's just a lot of opportunities like to apply for. I didn't even
Mhm.
realize how many companies work in the space industry. And
Yeah.
even NASA takes co-ops. There's a lot of opportunities for students to break into the industry. And for me, that's how I found out about it is, I just went out and I applied for an internship and I was able to get it. And that really was a great foot in the door to, one, see if this is something that I did want to do, and two, just know that it's possible to do.
Oh.
So I would say just, yeah, definitely get a degree in a science field,
Hmm.
and just uh, look for those opportunities and apply online, and apply to those companies. Because yeah, it seems like it's a small industry, but
Hmm.
there's a ton of opportunity there.
That's cool. All right. Well, thanks. And actually, you being here talking today, I'm sure is being inspirational to someone watching out there. So, definitely Caroline F., who asked you the question about are the rocket engines reused. Thank you very much, Sarah. Thank you so much for supporting Rocket Fever this year. And also, I want to thank Aerojet Rocketdyne very much. You know, your company has always been a good supporter of the Space Center, because of the historic connection. So thanks, and we're looking forward to seeing you at Rocket Fever 2021 or somewhere else in a virtual world.
Sounds good. Yeah,
Okay.
sounds great.
Thanks.
Thank you so much.
Thanks.